My dear students, very good afternoon. In this session, I'm going to start the module 4, which has two parts. One is control rectifiers, another is the voltage controllers. So today, in this session, I'm going to discuss about the introduction about the control rectifiers, classification of the control rectifiers, and also the applications of the control rectifiers. So what is control rectifier? So why it is called so? Dear students, you are already aware of the ordinary rectifiers which can built using the ordinary diodes. So diodes which allows the current to flow in one direction means which converts into the DC, but the DC is not what is that variable DC which is not controlled. The DC is not controlled in case of an ordinary rectifiers. So the ordinary rectifiers converts AC to DC, but DC is not pure DC, it is a pulsating DC which contains the ripple contents, and that DC is not controllable one. So in order to control the rectified output, so we go for the control rectifier. The demand for the control rectifier increases. So then the designers design the rectifiers. So where the output, the rectified output voltage can be controlled. So control rectifier can be constructed by using the SCRs or thyristors. Dear students, as you know, the difference between the ordinary diode and the SCR or thyristor. Ordinary diode which consisting of the two terminals, anode and cathode. But thyristors or SCR consisting of the three terminals, that is anode, cathode and the gate. So gate is the control terminal in the SCR or the thyristors. So this control rectifier which converts, what is that? The fixed AC into the variable DC voltage. Try to understand here. So what is the fixed AC means? 230 volts AC is the fixed the AC supply, that is single phase 230 volts 50 hertz supply that can be converted into the variable DC. So it depends upon the requirement of the load. For example, the battery charges. What is the capacity of the battery of the mobile? Maybe 5 volts. Okay. So the control rectifier which converts 230 volts AC into the 5 volt DC, that can be used to charge the battery of the mobile. So I hope you understood control rectifiers are the type of power converter which converts fixed AC into the variable DC and it is controllable. So here you are observing the diagram which shows input to this the converter is AC and output of this converter is DC, which is the variable DC. Okay, so AC to control DC is possible. AC to DC conversion so is possible by using of this AC to DC converter or rectifier. Okay, if you want to control the rectified output, then we go for the control rectifier. So look here. So the input to this rectifier converter is fixed RMS voltage and fixed frequency, as I told you, 50 hertz frequency for the Indian. And output is the controlled variable DC output voltage, and the phase controllers employed in the control rectifier circuits. So during the positive half cycle, what happens? Let us understand what is the status of thyristor during positive half cycle. During positive half cycle, so when the omega t is varying from alpha to beta, then thyristor current and load current begins to flow because thyristors are forward biased. The output voltage across the load follows the input supply voltage through the conducting thyristor. So at omega t is equal to beta, so thyristor turn off due to the AC line or natural commutation. So let us see the applications of the phase control rectifiers. Phase control rectifiers can be used in the steel mills, then paper and textile mills employing the DC motor drives, and which can be used in the AC fed traction system using the DC traction motor, which can also be used in the electrochemical and electrometallurgical processes, magnet power supplies. We can also use in reactor controls, then portable hand tool drives. And this portable hand tool drives like what is the drilling machines. Okay, there we are using this the phase count rectifiers, and also variable speed industrial drives and battery chargers, the mobile battery chargers, and also other chargers. We are using this control rectifiers depending upon the requirement of the load voltage, so the input supply can be converted. And high voltage DC transmission HVDC also we are using this control rectifier, and finally it can be used in the uninterruptible power supply systems. Next we'll move on to the classification of the phase control rectifiers. The phase control rectifiers can be classified based on the type of the input power supply. So look, if the input power supply is single phase, we can call it as a single phase control rectifier. If the input power supply is three phase, then we call it as an what is that three phase controlled rectifiers. So look here, single phase control rectifiers which operate from single phase AC input power supply, and also we have the three phase control rectifier which operate from three phase AC supply. Then the types of single phase control rectifiers. So in single phase control rectifiers also we have the different types, depends upon the load. So if the so it depends upon a load one, that is single phase control rectifier with high load and heavy load, and one more is that depends upon the output control. Suppose if the output control only in one off cycle of the input DC supply means, then we call that phase control rectifier as an off wave single phase half wave control rectifier. If the output controls both in both off cycles of the input power supply means, then we call that phase single phase control rectifier as an full wave control rectifier. So we have the two types. One is full wave single phase full wave control rectifier, and another is single phase half wave control rectifier, which depends upon the how the output controls during the positive half cycle and negative half cycle. Okay, and full rectifier once again classified in two types: intertapped and bridge control rectifiers. Okay, so this is about the classification of the what is that controlled rectifiers, and we can also classify the single phase control rectifier as a semi converter, off control bridge converter using two SCRs and two diodes. Here in the bridge circuit consisting of the two thyristors and two diodes to provide single coordinate operation, that is called as a single phase semi converter. Similarly, single phase full converter, fully controlled bridge converter, which require four SCRs to provide the two coordinate operation. Okay, so then three phase control rectifiers, we have the two types: three phase half wave control rectifier and three phase full wave control rectifier. Depends upon the input supply. See, look here, in this case the input is the three phase fixed AC, and the output is the variable DC. So here three phase control rectifier which converts three phase AC into the variable DC. Thank you for watching this video. So in the next session we will see the different classification of an what is it the single phase full wave controlled rectifiers.